Yeah, sure. Yeah, thank you, everybody. Thank you, Gino, for the opportunity to talk to our friends in Sao Paulo about Apache Flink. This is technology, big data technology, which is which has some buzz around it now, and you should be proud that this meetup is the first one in Latin America. So there is meetups in Europe and in US and in Asia, but this meetup is the first one in Europe. As you can see, the title here is Introduction to Apache Flink. What, how, why, who, where. This is the natural question that as a human we ask when we are in front of a new tool or a new object. Or yeah, I'm trying now to move to the next screen. Okay, here we go. So the agenda for today is the following. What is Apache Flink stack and how it fits into the big data ecosystem, how it integrates with the Hadoop and other open source tools, why Apache Flink is an alternative to other big data tools such as Hadoop, MapReduce, Apache Storm, or Apache Spark, who is using Apache Flink, where to learn more about Apache Flink. So this is our agenda for today. We started at our time here is 10 minutes past 4, so your time is 10 minutes past 7. Even if we don't go through every single slide, you will have the slides to continue exploring and learning at your own pace. The idea here is to share with you and within this 50 minutes or so, and also give you a chance to ask a question. So basically, when we say what is Apache Flink, we will briefly talk about big data in general, batch and stream processing, and then we will touch upon the execution engine, the API, the domain-specific libraries, the architecture, the programming model, and the Flink tools. You might probably saw this elsewhere. So what this picture is showing? It's showing Noah, and in front of him is a man, and behind him a lot of animals. So that's this shows the idea that in big data there is a lot of tools, and many of them they are named after animals. And here Apache Flink is no exception. It's a squirrel, and you will see that it's a new addition to the big data, and it's kind of like has some unique feature. And if you read that definition, so I adopted it from many other references, and basically it's a kind of customized definition. When we talk about big data, we refer to data sets which are large enough, so this is related to volume, and data streams fast enough, this is related to velocity, from heterogeneous data sources, that's about variety, that has outpaced our capability to store, process, analyze, and understand. So this is a tentative to have a definition which try to give us a quick idea about big data. When it comes to big data, we have mainly two types of processing. We have batch processing, and we have stream processing. So when it comes to batch processing, the paradigm is the following. You collect the data for a certain period of time, a day, for example, and you store it somewhere to be processed as a finite data set. So think about it. As you open a faucet, you fill it with water, or you buy your water in a bottle, and when you drink it, that's kind of like a batch processing. If we contrast this to stream processing, it's like there is a flow, so data is moving, and you are processing it as it is moving. So it's very important to contrast two types of processing, the batch processing and the stream processing. This diagram shows kind of like a typical design pattern when you have data that you are gathering, and you have a broker to store that data, and then you analyze it. Flink, in this context, is a very good tool for stream processing for data which is in movement. Also, it's good for data which is at rest. So what's unique about Flink? It allows you to process data either at rest or in motion. So that's what is important about Flink. Here we will touch on a few of the aspects of Apache Flink. So what this project originated in Germany, in TU Berlin, and then it becomes an Apache Flink project. Started as a Stratosphere, then became Apache Flink. Flink is a German word which means speedy or agile, and that's the logo that the project picked very quickly here. Remember, we are talking about big data, and mostly in the Hadoop ecosystem, we have many projects which are named after animals. Here, Flink is no exception, so it's a squirrel. It's the definition, as I said, in German, means swift and agile. And the color of the body is red because squirrel in Germany are red, so it's kind of like reflecting the roots of this project as started in Germany. The tail is colorful, as you can see, and that represents the Apache Software Foundation. It's kind of like this tool is telling us, I'm committed to being open source and under the Apache Software Foundation. So we were giving this talk face to face. I would have asked you about who knows about Hadoop or about Spark. What's interesting here in this diagram, this is an abstraction of any big data analytics tool. So you have different layers. At the bottom layer, you have the storage layer. Data can be in files or can be in streams, comes as streams, data and move, or can be in a database. And above it, in red, you have resource management, and then you have execution engine, and you have different type of processing. For those of you who are familiar with Hadoop, you will recognize that the database can be HBase, the storage can be HDFS, Hadoop Distributed File System, the streams, they can come through Flume, or now more and more Apache Kafka is becoming well known and mostly used for data and movement. Resource management, you have Yarn. Execution, you have your MapReduce. In the case of Hadoop, you have different tools for machine learning, a different tool for graph processing, a different tool for scripting like Hive and Pig, and you have a different tool for stream processing such as Apache Storm. So with Spark and with Flink, this is being changed. You still need to have a storage layer. You need still to have resource management. So neither Flink or Spark provide you that type of resource management or storage. It's agnostic to both, but it provides you a robust execution engine. And the idea here is that instead of having different tools, you have, as we can show, we will be showing later, different libraries running on the same engine. Apache Spark started this trend, and Apache Flink is taking this to the next level by having an execution engine which is mostly a streaming engine. So that's kind of like the differentiator here for Apache Flink compared to Apache Spark and compared to Hadoop. So I will skip this slide. So now you saw that abstraction, right? And how this translates to the Apache Flink stack. As you said, you need files, database, streams, and the tool is agnostic when it comes to storage. It can work in a local setup or in a cluster or in the cloud. As I mentioned, the major differentiator here is a distributed streaming data flow. And here you have two APIs, dataset API for batch and data stream API for stream processing. So when we say batch, that's for the data at rest. And when we say stream, that's for the data in motion. And here on top of it, you have different libraries. What's interesting here, Flink ML or Table or Jelly, they are all libraries part of Flink. So they are not other tools. So that's what's specific about this Apache Flink. So it has a robust runtime, distributed streaming data flow engine, and the libraries are all built on top of that engine. Here I'm using a different color, and this is very important. So if you have happen to have a Hadoop MapReduce application, you can run it on Flink as it is, because Flink provides a layer like adapter. So think about it as if you are using electronic device, and when you use it in let's say in Europe, and you want to use it here in the US, you need to have an adapter for the before plugging it in the outlet. Same thing here. Flink provides you an adapter to run your existing Hadoop MapReduce. Same thing for cascading. If somebody is familiar with cascading, that's an application which allows you to do ETL on Hadoop. The default execution engine is MapReduce, but here it can run on Flink, and it can also run much faster than Hadoop MapReduce. For example, in Spark, still you cannot run cascading on Spark. This is another differentiator from Apache Flink. Zeppelin, especially for the people who are doing data science, it's a very nice GUI, and that allows you to do kind of interactive data science. Also, it integrates with Flink. This is the major slide about understanding what is Apache Flink. How now Apache Flink came to existence with an original vision from Professor Volker Markel from Technical University of Berlin. So his idea is that he taking concepts from the MPP, massively parallel processing database, such as Teradata, and taking also concepts from Hadoop MapReduce, combining them and adding some other feature. So that's the vision for Apache Flink. So taking feature from MPP, taking feature from Hadoop, and adding few features such as real-time streaming, or iteration, or memory management, or advanced data flow, or general API. So this is the main vision of Flink. So I added to it, kind of like analyzed this Apache Flink tool, and came with, as the tool is being built, I noticed that there is more to this vision and philosophy, and I'm listing them here. So every time, all streaming all the time, you write like a programming language, you execute like a database, and also it alleviates the user from manually tuning the memory or dealing with the physical execution concept. Other things, you do less configuration with Flink, and you do little tuning. So that's the philosophy, and that's how Flink was implemented. It supports many file systems. You already saw that. It supports many deployment. I coined the word by OS, like bring your own storage, and by OC, bring your own cluster. So it's not dependent on a specific file system like Hadoop. You have HDFS. Here you can, as we saw it, you can work on Amazon S3, on any other, NoSQL storage, on any other type of files. Same here, you can run on your local, in local mode, you can run on a cluster on premise, and you can run on a cluster on the cloud. So it has good integration with Yarn, and also, as we already mentioned, that it preserves your investment in your legacy application. So if you have Hadoop MapReduce, you can run it on Flink. If you have an application that runs or was built using Apache Storm, you can still run it on Flink. If you have also cascading application, you can run it on Flink. So that's also a major differentiator. So to summarize, Flink supports many use cases, be it batch or real-time streaming, or machine learning, or graph processing, or relational queries. So that's what's good about Flink. And this is summarized is this picture. So that's the symbol for Flink. And here you have your two API. be it the data set or data stream, and you have different types of processing, real-time, batch, machine learning, and graph processing. The beauty of this tool is that these are not other tools that you need to integrate with Flink, such as in the case of Hadoop, but here they came built in and also come from the Apache Flink tool. There is something actually interesting to watch. Recently, Google, they did open source a tool which originally called Google Data Flow. What's interesting about this tool, instead of having two APIs, one for batch and one for streaming, with Google Data Flow, or now it's called Beam, so that's batch and stream, that's called Beam. You have one API, and it's something that to watch. And this is how this works. You write your code using a single API, and you have now the option of running it on your local machine, or you run it on Flink, or you can run it on Spark. So this is one of the major trends now in big data, unified API and different execution engine. So that's kind of like one of the trends, and I share here a couple references with you. We can say that Flink is the fourth generation of big data analytics. Originally, Hadoop MapReduce supports only batch. With Tez, which came from Hortonworks, you support batch and interactive, especially through Hive type of query. With Spark, Spark took it to another level. You support batch, interactive, near real-time streaming, and iterative processing. It's important here to say that Spark streaming does not support real-time streaming like in Flink, but it supports near real-time, and we'll talk about this later. So what Apache Flink is bringing, so it's a hybrid engine which supports both streaming and batch, interactive, obviously, similar to Spark, but what's new is near real-time. And another new thing, which is called iterative processing. This type of processing is very useful for machine learning and for graph processing. So when it comes to the paradigm, the Hadoop was based on MapReduce, Tez was based on DAG, direct acyclic graph, and the Spark was based on resilient distributed dataset, while Flink, with its iterative processing, is based on cyclic data flow. That's why I am coming with this classification, saying this is first generation, Tez is the second generation, Spark is the third generation, and now Flink is the fourth generation. Similar to what you have in the wireless networks, 4G, 3G, and obviously, what does this mean? There will be another generation, definitely, 5G, so things keep evolving. For now, this is my assessment of the different big data analytics tools and how Flink is